just, S is the parameter, so it's time, it's function of time. This is function of time. What is this function?
Wagner.
Exactly, this is Wagner function. Very good. Why? Because we said that Wagner solved the step input, and he said the circulatory lift is equal to your steady value multiplied by this function. So it's going from half here to unity there. This is Wagner function. And it reaches almost unity in 6 to 8, as S equals 6, around 6 to 8. What does it mean? It means that an airplane, this is a step change in the angle of attack. Okay? Means that an airplane reaches its steady state within travel distance 6 to 8 semichord, 3 to 4 chord length. So the chord is 2 meters. We're talking about 6 to 8 meters. With this very fast velocity, it's a fraction of a second. So this is why sometimes in real applications we really ignore this transient thing. Okay? But again, in high unsteady maneuvers, sometimes we cannot ignore. Okay? So this is Wagner. This is the definition of Wagner function. We'll talk about this form later on and how Wagner is related to Durson, that stuff. But we'll take, unlike to Durson, to Durson, there's a great privilege. We have an analytical expression for C of K. Give me any K, I'll give you the corresponding C of K. We have nicely written analytical expression. There is no nicely written, it's like this. But, you know. So give me your S, I will do it specifically with this S and give you a number. So we have a table, but we don't have an analytical expression for 5S. So this is why people looked at, because the step response is very important. We'll know why next time. So they looked at approximations, analytical approximations. So we have Garrick in 1938. He said 5S is approximately S plus 2 over S plus 4, and this is within 2% error for all S. So it's not bad. Okay? But if you're a dynamics and control person, you will not like this, because the step input, this is the step response. This is your output to the step input. Okay? It's never, S is time, just to give you the idea, because it's not Laplace. We never seen in our dynamics and control courses T plus 2 over T plus 4 as a step response. It's always exponential, right? So if you're a dynamics and control person, you'll not like this, and we'll emphasize this concept next time. It's always exponential, so this is why R.T. Jones, 1938, the same year, W.P. Jones, R.T. Jones, by the way, was the guy responsible for the switch of the wind tunnel at NASA, Langley, and he became a scientist. He published papers on unsteady aerodynamics. He developed the theories on unsteady aerodynamics, even three-dimensional wings and unsteady aerodynamics. So they said, well, we need to approximate this guy by an exponential, A1 E negative B1 S A2. So please think of S as time. S is really time. So the guys in unsteady aerodynamics make it very confusing because we usually think S is Laplace. It's time. So for R.T. Jones and W.B. Jones, both A1 is 0.165 and A2 is 0.335. You can see that immediately together they have to sum as half the value of Wagner at time 0. But this guy developed. So what are they trying to do here? What are they trying to do? They are trying to use this formula and get the best values of A1, B1, A2, B2, such that what we get from here exactly matches Wagner. It's curve fitting, right? It's curve fitting by exponentials. So this guy found these values, 0.0445 and 0.3. This guy found slightly different ones. There is a series of approximations. Sears in 1940. Sears was a student of von Karman, and he became a prominent in the field. He did this expression, and we'll talk more about other useful approximation. This is the most useful one because it is in terms of exponential. We will use it to develop a transfer function next time. He said it's almost a phi is 1 minus large phi, and this is an expression for large phi. S times log S over 2 plus gamma Euler constant minus S squared log S over 2 plus gamma squared yada yada. We'll continue next time. You have any question, guys? Please. If you have a question, just stop me. Yes, Joseph?
So this is saying when you change the alpha in a step, immediately you get half the lift?
This is a very, very good observation. Yes, which is not realistic. I mean, we will discuss that in detail sometime, hopefully next time or so.
So is gamma a gas constant?
I'm sorry?
The gamma over here, is it a gas constant which is 1.4?
The gamma is Euler constant.
1.4?
No, 0.577 something. Well, just Google it, Euler constant. Yes, Joseph, and this is, you can see it in Tudorson. So Tudorson is the frequency response of this guy. So Tudorson, here is the magnitude. The high frequency limit for infinite frequency, you should get 0, but here you get half. So we'll talk about these things next time or one time. They're interesting.